anyways, we are doing 6.2 notes today. Oh, let me find where I put mine. All right, so we learned in 6.1 how to go back and forth between atomic mass and atoms. So basically, how many atoms do you have, and then how much does that weigh? And we learned right here is especially important information. First, determine what information they give you to start with. Second, make sure the units you start with go on bottom of your conversion so that they cancel out. And what you're looking for will go on top. So that's super important. We'll be using that again today because we're going to look at the mole. Now, I think we've done some work kind of leading up to conversions that we're going to be doing with money, with weights, trying to use things that you guys are used to hearing, and I'm going to do that in the notes also. But I think that's why kids struggle with this, is because the numbers are so big. Because think about this, when I get a grain of salt, and I'm looking at a grain of salt, there are so many NaCl molecules in that 1 grain. We cannot see them with the naked eye, so there's a ton of them, which means we get these really huge numbers in chemistry. And those big numbers tend to confuse us, and we're hearing new terms that we've never heard before. So for instance, to get started here, I'll ask them how many people are in the picture below. So if you're looking at those cutouts of those people, how many are there? Well, if you count them up, there are 12 people there. So what's another word for that number? So what do I use when I go get 12 donuts or something like that? The word that we use for that is dozen, right? So then I'm going to ask them, well, how many legs are in the picture below? Well, if you count the number of legs, there are 24, or we would say 2 dozen. Now, there's a reason why I do this. Because we can see that even though we only have 1 dozen people, those 1 dozen people have 2 dozen legs. And I used to say this with moles. I used to say, oh, 1 mole of water has 2 moles of hydrogen. And people would be like, that makes no sense. How do you have 2 moles of hydrogen if there's only 1 mole of water? And well, it's the same reason why I can have 2 dozen legs, even though I only have 1 dozen people. So I put this on here because kids always tended to get a little confused when I would tell them stuff like that. And we'll see that later on, and I'll refer back to this picture. All right, so let's look at the water molecules down here then. It says, how many H2Os are there? And the H2Os are the red oxygen, and these are your 2 little hydrogens here. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I've got 12 H2Os, right? I've got a dozen waters. How many oxygens are there? Well, the oxygens are the red molecule here, not molecule, element. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It's the same as the people, right? Now, how many hydrogens are there? That's the white. So let me erase some of this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. 24. It's like the people we saw. Yes, I have a dozen water molecules, but I have 2 dozen hydrogens. Do you guys see what I'm saying there, what I'm doing? Because when I change this word from dozen, and I change it to moles, I have 12 moles. Let's just say dozen. Let's say that all of a sudden I'm like, I have 12 moles of water, but I have 24 moles of hydrogen in that. That's when kids I would always have kids being like, but how is that possible? Well, the same way it's possible that you have 12 dozen waters, but 24 hydrogen, 24 or 2 dozen hydrogens, okay? So let's move on from there. We'll bring that up again here in a little bit. I'm going to use this formula for sugar, which is C6H12O6. And now we're going to use this term mole. Instead of saying a dozen, I'm going to say mole. All right, so how many moles of carbon are in 1 mole of sugar? So this is 1 mole of sugar. 1 mole, it's not going to let me right there. 1 mole C6H12O6. So if I'm looking at that, 1 mole of sugar, I have, is it 1 in here? Carbon, I have 6 moles of carbon. How many hydrogens? 12. It's not going to let me underline. I don't know why it's not letting me write, guys. right, so even though I have 1 mole of sugar, I have 6 moles of carbon, I have 12 moles of hydrogen, I have 6 moles of oxygen. Just like I showed you above, how I could have 1 dozen H2Os, but have 2 dozen hydrogens. Okay, so same thing. So like a dozen is a certain number, a dozen means 12. A mole means a specific number, just like a pear means 2, a ream of paper means 500, a case of soda usually means you get 24 in a case. These all mean a certain number. Di means 2, tri means 3. A mole means, and this is where these numbers get super large, right? Because these particles are so tiny. So 6.022 times 10 to the 23rd. That is the number. So think about that. If you were to write that out, 6.022, now times 10 to the 23rd, it's a positive superscript up here, so that means I'm making this number bigger. 1, 2, 3, and then I'm going to add 20 zeros. 12, 13, 14, 15, 16, 17, 18, 19, 20. Look at this number, guys. This is the number. This is what 1 mole equals. I don't even know how to say that. I probably should. I probably should look that up and see how do you even pronounce that number. But that is 1 mole. So these particles are so small that we have to have a number that large. All right, and it's Avogadro, Amadeus Avogadro, who came up with this number. So it's called Avogadro's number for that reason. 1 mole of hydrogen, so just like if I said 1 dozen of donuts is 12 donuts, 1 dozen students is 12 students, 1 dozen pencils, 12 pencils, 1 mole equals 6.022 times 10 to the 23rd, so 1 mole of hydrogen equals 6.022 times 10 to the 23rd atoms. Now this is particles, atoms, anything. We happen to be looking at atoms. If I wanted a mole of students, I would have 6.022 times 10 to the 23rd students. But everything I'm doing in chemistry right now is atoms, or molecules, or particles. So 1 mole of oxygen, 6.022 times 10 to the 23rd atoms. I could have said molecules there if I wanted. It's still the same thing. 1 mole of H2O, 6.022 times 10 to the 23rd. All right, so we have an equation for what I'm going to use for here in a second. Let me erase this. So 1 mole equals 6.022 times 10 to the 23rd. You guys just sat there and heard me say it over and over again. I will tell the kids that they can write this down on their periodic table if they want to. I suggest that you do. If I tell you guys you can write something on your periodic table, it usually means it's pretty important and you probably want to write that down. Excuse me.
If you are involved in singing the dance, please come to the cafeteria at this time. Thank you.
It's just like you're in school real time. All right, so guys, I'm going to cut this off because I didn't know about this meeting, but I have a meeting apparently, so I'm going to cut this off right here, and I will have a part 2 of the notes where we go more into this. It'll pick up. You guys won't even know that I've left because I'll stop this, and then you guys will get to just click on the second part.